In this video, we're going to demonstrate the actual process of analyzing circuits using phasors and impedances, analyzing circuits in the phasor domain. We've already pointed out that in the phasor domain, or that we can analyze a circuit in the phasor domain by representing the voltages in terms of phasors, the currents in terms of phasors, and the impedances, or representing the effects of these capacitors, resistors, and inductors in terms of their impedances. So first of all, let's just represent phasor V, the source, as having an amplitude V sub m e to the j theta. So we're representing this time domain signal as its phasor with an amplitude of V sub m and a phase shift of theta. Now, the impedance of the capacitor is equal to 1 over j omega c. The impedance of the resistor is just equal to R. And the impedance of the inductor is equal to j times omega times L. So we'll represent that, or show that here, as this impedance is 1 over j omega c. This is just R. And this impedance here is j omega L. Now, in the phasor domain, there will be a current flowing that we'll represent as phasor I. And with these representations, let's go ahead now and write a Kirchhoff's voltage law equation in terms of these phasors. Starting at this point and going in this direction, I'm going to add up the voltage drops, which means the voltage increase will be a negative. So I'll have negative V sub m e to the j theta. Plus, now I'm going in the direction of current flow, so direction of current flow represents a voltage drop, and it will be a plus. The voltage drop across the capacitor is just the impedance of the capacitor times the current, or 1 over j omega c times I. Plus the voltage drop across the resistor, again going in the direction of current flow, will be just R times I. Plus the voltage drop across the inductor will be the impedance of the inductor, which is j omega L times I. And the sum of those terms equals 0. Now, this is not a function of I. In fact, this is the constant associated with the source. So let's bring it to the other side and factor out the I that is common in each of those terms. We have then that I, not equal to I times 1 over j omega c plus R plus j omega L is equal to V sub m e to the j theta. We now solve for I by dividing both sides of the equation by this term in parentheses, and we have then I. The phasor representation of I is equal to V sub m e to the j theta divided by 1 over j omega c plus R plus j omega L. Phasor I, the phasor representation, this is calculated by doing that complex division.